Right, we've got part of the motor here. This is the motor that spins the platter, and we've got the stator here, which is a lot of windings on an iron core. Have a look at that in a minute. This is the rotor, so this is a permanent magnet here which will have a number of poles which align with the coils here, and when you energise these in a certain order then it will cause this to rotate. This is aluminium, feels quite light. It's been machined, I think. We can have a look at that under a microscope later maybe. And it's got some screw holes there which the platter was screwed on with a sort of keeper on the top, a plate which is screwed and sandwiches the platter. So this is fairly interesting. This has got several layers to it. It's not a solid piece of iron. I've filed a bit away here so you can have a look at the laminations, and that's designed to reduce eddy currents in the metal. If that was solid metal there'd be quite a lot of eddy currents which would oppose the magnetic field that the coils are trying to generate, and that's something that's seen in transformers. It also probably makes it easier to manufacture because you can stamp out the patterned flat laminations just using a stamping machine and then glue them together. They need to be insulated from each other. If they're conducting and you haven't got an insulating coating on them, then obviously they're a solid bit of metal again and you'll get the eddy currents. So I'll put that under the USB microscope and let's have a look at the laminations. So you can see them there. There's not very many laminations in this. If I get that into focus, I think there's 1, 2, 3, 4, 5, 6, 7 or 8, something like that. And you can see the wire there, which is wrapped around it. And then they've got some, well, some sort of. Oh no, that's me. So there's, I've got some epoxy there which I was using to hold the windings in place while I machined the laminations, because otherwise the wires would fall off as it's done here. You see all the windings are detached and just falling away. So that's the guts of the motor that spins the platter round, and the rotor is the bit that's going to be attached to the platter and will actually spin round. You can see there's machining marks there. Have a look at those on the Olympus. But this has been machined out of a piece of aluminium, some sort of alloy. On the other side we've got some screw holes that hold the platter. There's 3 there. And inside we've got here a permanent magnet. You can see it's sticking to these tweezers. And that's what's going to interact with the coil, and you can feel, or I can feel, poles on there. So there's a pole there, another one there, another one there, and so on. And as you energise the coils in the stator, the rotor will be attracted and repelled and spin round, and as you change the frequency of the pulses you apply to the coils, the speed of the motor will change. So that's fairly simple. And this spins on a bearing, the motor bearing, and I've got that here. Now the motor bearing, there's actually a pin, this pin, which will fit inside a bearing, and this is just a smooth machine pin. It does have a groove in there which is interesting. I think that's something to do with the lubrication, which we can have a look at now, because that is unexpected. So this is the bearing that pin would actually fit into, and if you look down inside there, I'll just change the focus a bit there maybe, you can see that there's grooves in there. You can see that, if I can just do it here and here, there are 2 grooves that are angled to point towards each other, and over here there's 2 more grooves, and they go all the way around the inside of this hole where the pin will rotate. and I believe this is a hydrodynamic bearing, so the lubrication will sit here and here, and as the pin spins, it doesn't really matter whether you view the pin or this spinning, really, it's just relative motion. The lubrication will be pushed along the grooves, and on this side they'll go in that direction, on this side they'll go in that direction, so they'll continually be forced to the centre of the grooved area here and here, and that will leave you with a bearing, a fluid bearing basically, here and here, and that is what the pin will float on. So the platter and motor will be floating on fluid. So that's a pretty complicated bit of machining going on in there, which I'm assuming is machined. It might have been cast, but that's a fairly impressive artifact, I suppose. The rest of it is just solid, what is it? It might be brass actually. It's got a yellowish tinge to it, so that might actually be brass. I think it's been plated with something. You can see the yellow there. Now the heads, they also spin on a bearing. Now it's a completely different bearing because it doesn't run very fast, and it really just needs to be very rigid, and that bearing is in this housing here, and there's two areas, one here and one here, which is where a couple of ball races lived. Now this is what's left of them, as I've dismantled the bearing somewhat. So you can see here there's a plastic holder, I suppose, for the balls, and the bearings, the balls themselves, the ball bearings, would actually fit in those recesses. And then there's some spring washers and some other associated bits of metal, and the ball themselves, or the balls themselves, would run in this bit of metal, if I can get it. Let's try some different tweezers. So this is the ball race itself, and the balls would run inside, if I can point to it, inside here. You can see there's a curved ring that runs round inside, and the balls, I've got them here, some of them, I lost a lot of them. These are the balls here, they're about 1 millimetre in diameter, and they'd run inside this race. And then there's the plastic, of course, that they sit inside, that they run around here, and then there'll be an interior bearing as well. So there's an exterior and an interior to this. And there's two of those on this bearing mount, which is, I suppose, the spindle, and this is the ID of the bearing. The OD would be pushed into the case, the aluminium frame of the disk drive, and that's a very low friction, very rigid arrangement. So they obviously didn't want the head arm having any play at all. I mean, that's quite a bearing for such a light arm. But then with the tolerances of the tracks and so on, it's going to have to be. So that's the bearings and the motor. I'm on the Olympus here, and I'm currently looking at the edge of the rotor. So this is the far edge, which has got the magnet inside it. So this is on the side that's got the permanent magnet, and you can see there's some machining marks there. So this indeed is a machined rotor, and you can see the gradual angle of the radius of the edge there. The magnet itself is here. It's this black surface that we're looking at now. So this is actually the magnet. Maybe we can see some grain structure there. So this, I think it's a ferrite magnet, so that's probably a sintered process. Yeah, completely different, but that's the edge there of the magnet, dropping off down to the aluminium inside, which I'll bring into focus with a bit of luck. There we go. So inside, so this is the surface that's actually inside the ring of ferrite. You can see that that's been machined as well, so you can see the machining marks there. So quite a lot of machining going on this part. It would probably have been CNC'd in some way. So you can see all the machining marks on that large surface. So if I take it out now and flip it over, so this is the other side, this is the side the platter was bolted to. Let's have a look at that. Again, that's been machined in a similar fashion. And you can see some marks there where I've actually hit it and scratched the surface while I was doing things to it. You can see there that scratch has skipped across the top of the machining marks. All sorts of dirt and damage has been done to it. So it's definitely been machined. See if I can find a screw hole. I think that's just, yeah, there's a screw hole. So that in there is the thread. I wonder where it starts. Let's see if I can find the start of the thread. So that's the thread that goes off down there into this circular piece of metal. Can we find the start of the thread? That would be... I think it's been countersunk, so I don't think that's going to be possible, because there's a countersunk area here where it's cut into the machining. So that's an interesting bit there where the countersinking is. You can see it's cut into the machining marks. But yeah, so the rotor definitely machined, and it looks like aluminium.